Right, all right, hello everyone. I'm Sebastien. For those of you that don't know me, this is my website, this is my Twitter. If you want to moan about how terrible I am as a speaker afterwards, please do it on Twitter, for I do not read emails. Today we're going to be talking very, very quickly about the death of Hypermedia. Now, if we go back a little bit in history, you will remember that many, many years ago, we started talking about building Hypermedia APIs as a thing, as opposed to REST APIs, because the REST word had been used and abused by many vendors to provide subpar solutions that had very little to do with REST. So we moved the goalpost a little bit, and we decided to start talking about Hypermedia. What is Hypermedia? It's the capacity to have various bits have links to various other bits. And so we started talking about that in 2008. And now that is 2016, everybody has graduated. No one questions having links anymore. No one questions using HTTP without screwing everything up anymore. So we've progressed. And as such, it is time to move the goalpost a little bit. So when I say Hypermedia is dead, we need to define a little bit what Hypermedia is. First, and this is still part of the REST architecture or the web architecture, or how the biggest distributed system in the world actually functions, and has been for 25 years. One of the core pillars of REST is resources. What is a resource? What defines a resource? Anyone? A URI. Anything that has a URI is a resource. Be it that it exists or not, be it that it's accessible or not, be it that it returns a 401 or I'm a teapot. So resource is anything with a URI. What is URI? What does it mean? Yes, Uniform Resource Identificator. Identifier, even. Identificator? I like that word. Okay, I'm going to reuse that one. Okay, so it's an identifier just like an ID, just like you have in your databases. On the web, we don't use ints, we don't use IDs, we don't use media types that have an ID with 4 in it, unless you completely misunderstand what URIs are. The core identification of anything that has a name, the name is the URI. So then what made the web is the capacity to link to those URIs. This is a link. You can see there's an HTML link. It's probably an HTML2 page, because it's in capital letters. And it goes to json-ld.com/about. The link allows us to go from resource, which is the current page, to the next resource, which here is my about page. And then, a couple of years later, around HTML2 days, so I know it's new technology, it's from '94, we have what some people call typed links. So now I have a resource, which is a thing that I gave a name to, because it's useful to give name to things you want to talk about. And I'm going to link to another thing, but I'm going to tell you what the link is about. I'm going to qualify the link. That's why we call them typed links. For example, here, oh, did I do that? Is it vibrating? Am I getting things vibrating just by moving? This is extraordinarily exciting. Okay. So the page goes to /about, and the /about is a relationship of author. So my resource has a link to another resource, and we qualify that link by saying that that link is actually the author of the current page. All right, everybody's happy with the rel values? Everybody knows them? I know, very new tech. 15 years is a very short time in IT history, because .NET 1 was just out, right? Something like that. Okay, so then we built a whole bunch of architecture on top of XML, and then we decided, let's just kill XML. We know what we'll do. We'll use a much better language, JSON, and it doesn't have links. So that's kind of problematic, right? For web language not to support URIs, just not having the concept of a URI. But it is what it is. So a lot of people started building a bunch of media types. How many of you use HAL? Only that? How many of you use another link-enabled JSON format? Who doesn't use JSON? Who has no arms? Very good, very good. Okay, so a bunch of people created media types that allow you to channel a bunch of data and add a bunch of links to them in a structured fashion, right? So here I've got the links element with an underscore, because that's how the spec is written, and you will see the relationship self and author, and then a link. Going to it, this is a standardized way to have links in JSON because JSON kind of forgot to have URIs, which is funny. This is considered by some people to be how you do great APIs because you have a standard way of describing links. Unfortunately, if I'm an HAL processor, the only thing I understand is what the specification gives me, right? What the specification gives me is the links element. Everything else in that document is completely opaque and completely not understandable, right? I'll do that again. See, the title here, if I'm an HAL processor, I have no understanding of what it is. So, as usual, you know, it's not just HAL, there's a lot of formats, Siren, JSON API, there's a bunch of others. Give me others. Give me others. No one knows? Collection JSON, Siren, Uber. There's a whole bunch of languages that do the same thing. So what did the standardization bodies out there decide to do? There's a lot and lots of ways to formalize links. We know how we'll solve all that. We'll just create yet another one. And so JSON-ld was created, and JSON-ld stands for JSON linked data. The feedback is really high. Is it possible to just reduce it a tiny, tiny bit? So I get a lot of my own voice, and it's I'm not used to it. Okay, so perfect. JSON-ld is a format that allows you to write your JSON like you normally would, and to annotate. For example, here I've got the author element, which has a little bit of string. Now, if you're a JSON processor, this is a string key and string value. You can't see anything else, right? But if you add JSON-ld on top of it, you can define that author is actually a URL. So you can define it as a URL, and define that it's actually an entity by saying that the type is ID. So basically, what I'm saying is author is actually a URI, and it describes a resource. And I can do that whatever format comes along. It's a little bit like taking your document, your static document, and taking a little paintbrush and saying this thing is a URI, and this thing is a link, and this thing is a resource, and this thing has this relationship, separately from defining your static content. So I think that's pretty cool. But they didn't stop there. They created, or are creating right now, something called Hydra. And Hydra is not just about reading links and being able to formalize links. It goes a little bit further than that. It creates hypermedia controls. Or if you want to be a little bit more laid back, forms, right? So here, for example, we can see the resource defines a context. Don't worry about that. That's not very important. But you can see that we're talking about the about page, which is the same one we've been talking about since earlier, and that I create an operation called the delete resource operation, where you can tell me to bugger off by doing a delete HTTP method, and not verb, on the about resource. By the way, please don't try this, because I don't know, maybe GitHub gets a bug and then my about page is gone and I will have to bugger off. Thankfully, I will bugger off eventually, before we're already halfway through the allocated time. Now, the interesting thing about all this, of course, is that all these links are actually making assertions. All this information that we pass in when we design web API, we tend to put them into a black box, right? Because we like our RPC style, and then we put links on it because it makes us feel less bad about doing RPC over HTTP. Because if you slap a link on it, it's popular, it's no longer RPC. It's not the case, by the way, but it makes us feel better It makes us feel better. But what is important about information is what we can extract in a generic fashion out of an API and try to reason about. We access an HTTP resource. We have a bunch of methods that exist. We have a bunch of status codes that we can reflect on. A 200 is going to say something. A 400 is going to say something. All these are defined generically across all resources across the whole internet. This is why REST is powerful, is because we reuse things that have semantic values for us to reason about the resources we have. And so, for example, just the fact that I have this little link that I had earlier is already creating a whole bunch of assertions I can make about my system. And this is why we do resource modeling. This is why we give name to things. Because when we give name to things, we can make assertions about them. So, for example, I can say that the thing identified by the URI as /blog is a web page. The author of that web page is this link, which is a /about. The /about actually is a person. I can encode that very easily by using a class. And that person identified by that URI has a name, which we will, for today, call Serial Seb. It's not my actual name on my password, as you can imagine. But it's still a pretty cool name, I think, if I may say so myself. So we have all these assertions, and this is where I'm going to now give you the capacity to look very, very intelligent in your next conference. We have a page, and we define that as an author for that page, which is another thing called /about. It is the me resource. So this is called, on the left, the subject. This is a current page that has the link. We have a predicate, which is that link relationship. We know that the relationship is going to be an authorship relationship. The thing I'm linking to is going to be the author. And this is the object. This is what we call tuples. So there you go. You got your tuples there. So if you want to look smart, instead of saying I'm creating links, you can say I'm creating semantic tuples and making assertions. We can format using, this is a turtle. It is. It's a very excitable turtle. We can use the turtle format to format exactly the same thing here. I can make an assertion about my web page, which is serialseb.com/about. It's a person, because I'm using a vocabulary called FOF, we'll go back to that, and it has a name called Sebastien Lambla. Now, each of these assertions is a tuple, and each of those tuples can be multiplied across the data. So this is where now you can look very, very intelligent in your next talk. This is called directed graphs, right? This is graph theory right there. We have a bunch of nodes or edges, and each of them has links between them, the little arrows, right? So you can call them edges if you want to be edgy. Now you know about directed graphs. You can quote that term and look very, very smug in your next talk. That's what I do. So what is very interesting with having that information is that if you think about what we actually do with media types, we try to adopt existing media types to have semantic information that is shared, like links, but the rest of the payload is completely opaque. I need to know the GitHub API to deal with a GitHub API. But the definition in GitHub of what a name is going to be completely disconnected from the definition of what the Office 365 API is providing me as a name. And there is no way to reconcile the two if you're a machine, because these concepts are not modeled in a way that can be glued back together. And what we're creating when we create all these APIs is a whole bunch of small walled gardens where you're asking every single person that's going to integrate with you to have a completely new definition, completely new set of terms just for your company. Now, if your customers love you, that's great. And if they only talk to you, that's even better, right? It's the vendor lock-in. If you succeed, well done. Ask Microsoft. It doesn't last too long, so be careful. But while it lasts, it's pretty cool. Unfortunately, those vocabularies that we define for each of our APIs are segregated. We can't reason about them. And when we can't reason about them, we can't reuse code. So every single API is a new piece of code with a new media type, with new values that are completely incompatible with the previous ones, and we can't make any sense of it. As human beings, we may think and reason, oh, there's a first name there, it might be the same thing as that given name property they have. But I'm not sure because, there's no way for the two to connect. So I'm going to say that by using linked data technologies, custom media types are dying. And the reason they're dying is because continuously creating custom media types and custom walled gardens and custom vocabularies that you have to get people to adopt is preventing a whole bunch of applications to reflect on your APIs. How would you use an API that is enriched with semantic data? I hear you ask. Well, for example, one project that I nearly got off the ground was monitoring all the traffic across APIs. And because the documents that describe each of the properties in the JSON in JSON-ld can be external to your API, we could now map information completely random, completely based on what developers wanted to do on their API, and map those to specific entries of vocabulary. A first name is a first name. The customer ID for that team is actually the same customer ID concept from the shared vocabulary that we created. And then you can start creating global rules that apply to the whole business, which we call ontologies, things that allow you to reflect about the information. A customer may have a quote for a car, and in that quote there's an address. They may also have a home address for the home quote they may do on their price comparison website. Not that it is in any way the business I was working in at the time. But you can start graphing all that information and answer very complex questions without developers having to update the search engine. If we have semantic information in our payload, and this is what JSON-ld provides, we can now extract useful information, put it into a graph database, extract it into a SQL database, ship it in log files through pigeons back to a country where it's very cheap for people to look at that manually. I don't know. However you want to analyze that data, we now have enough information to answer very useful questions, such as, is the person that just bought a car is also moving? Should we also try to requote their home insurance while they're asking for a new car insurance, for example? And so the next step in all this is creating vocabularies, what we call ontologies, a set of terms that you can reason about, for which you can add rules about, and start sharing them across the industry. We already have a lot of them. If you have an open source project, back in the days, there was something called a DOPE, I think it was called. It's a pretty cool name. Which is a project description that allows you to extract useful information from your project. If you are talking about people, start annotating them with Dublin Core. Everybody knows Dublin Core? Everybody's been using Dublin Core for a long time. No one remembers. Now, you think all this stuff is very remote. I will finish by saying that media types that you build custom are dead. Using and reusing ontologies is the future. And that future is today, because if you want to continue being indexed on Google in the next couple of weeks/months, you need to start using JSON-ld in your web pages. How many of you have seen schemas.org? Schemas.org is an ontology. You're going to have to start annotating your content with JSON-ld. So this future is now. Think about how you can apply that to your APIs and start unleashing your own data. So this is all I have. That way we can catch up on the late starting times of everyone. Has anybody got any questions? No questions. Okay, well, if there's no questions, please talk to me on Twitter. Thank you very much. I will be all afternoon drinking somewhere, so please come and see me if you want to chat or tell me how wrong I am. I'm always very happy to have conversations. Thank you.